The day 10 of Advent of Cyber. Let's dive into the story and see what's happening in the city of Wereville today. What is the Bash Bunnies and not the Bash Bunnies, the Bad Bunnies are up to in the city of Wereville. Diving into the story, we see the Best Festival Company's Security Operations Center was in chaos. Screens flickered, light flashed, and sounds of alert echoed through the room like a digital thunderstorm. The elves rushed between the consoles, their face lit by the glow of red and orange warnings. It was raining alerts, and no one knew where the thunderstorm had begun. Whispers spread through the SOC as tension filled the air. Something strange was happening across the cloud environment, and the timing couldn't be worse. As the blizzard of alerts grew higher, one name surfaced among the worried elves: the elf, the evil Easter bunnies. But why now? And what were they after this time? Let's get into the learning objectives before we get into the story and SOC analysis and all those stuff. So here they say our objectives of today is to understand the importance of alert triage and prioritization, explore Microsoft Sentinel to review and analyze alerts, correlate log to identify real activities and determine alert verdicts. And they've given us some connecting connection details. It was completely different when I recorded yesterday. Again, I'm recording this for the third time, I guess. So it was completely different. I even tried logging in and it seems to be working fine today. So with that, let's move to the next section of it's raining alerts. Mix Kitty was notified that it's raining alerts. By the way, wasn't Mix Kitty kidnapped? Maybe we'll have to deal with the side quest for that, but let's get into the story here and not go into a different tangent. Mixkitty was notified that it's raining alerts. Something unusual is happening within the Azure tenant. The dashboards are lighting up with suspicious activities, and early signs indicate a possible attack from the evil bunnies. The Best Festival Company must act fast to survive this outslot before it affects the entire season's operations. Before investigating these alerts in Microsoft Sentinel, MixKitty must step back and understand what's happening. When alerts start flooding in, jumping straight into each one isn't efficient since not all alerts are equal. Some are noise, others are false positive, and few may indicate real threats in progress. This is where alert triaging becomes critical. Triaging helps security teams identify which alerts deserve immediate attention, which can be deprioritized, and which can be safely ignored for a moment. The process separates a chaos from clarity, allowing analysts like Mixed Kitty's SOC team to focus their time and resource where it truly matters. Alert triaging. Now let's continue the discussion about alert triaging. In the previous section, we introduced triaging and why it is essential. This time, we will focus on how to approach it, what to prioritize and what to look for, and what to do right after an alert. When multiple alerts appear, analysts should have a consistent method to assess and prioritize them quickly. There are many factors you can consider when triaging, but these are the fundamental ones that should always be part of your process of identifying and evaluating alerts. And the key factors are the severity level. Review the alert's severity rating, ranging from informational to critical. Why it matters indicates the urgency of response and potential business risk. Now, what they mean is that whenever we see an alert, there could be an alert of information, maybe like systems update is available or something like that, to something very critical. Or there are mediocre things also, such as there was some memory block or anything like that. So all those things also come in the range and the spectrum of information to critical. While we look at the severity level that we need to focus on, it gives us the urgency of time that we'll have to spend on a particular incident rather than just paying attention to all of the log that we see. Timestamp and frequency. Identify when the alert was triggered and check for related activity before and after that time. Helps identify ongoing attacks or patterns of repeated behavior. Meaning that when we identify the triggered alert, is there any activities before and after it which could potentially say that, okay, this PowerShell script was executed, and because of that, this alert was generated. and this is leading into these many activities. So it basically helps us to see what's exactly happening and what triggered that happening to happen on that alert response. Attack stage. Determine which stage of attack lifecycle this alert indicates. Maybe like reconnaissance, persistence, or data exfiltration. That it gives insight into how far the attacker may have progressed and their objectives. Now that's important because we want to also know what is exactly happening. Is the attacker stealing away some data? In that case, we'll have to pay more attention and prioritize everything to lock down the servers such that no sensitive information is disclosed or any ransomware such attacks are successfully exploited. But if it's a reconnaissance, there's still a prioritization of blocking down everything, but the methods and the way we are going to be doing is going to slightly differ, and the intensity of the worriness that we are going to have is going to be still differing in such cases, but still all of them hold the same level of tension when we are in the SOC team dealing with some incident. Affected asset. Identify the system, user, or resource involved and access its importance or to operation. Prioritize response based on assets importance and the potential impact of compromise. Now, what are the affected assets? Maybe like a computer or a network or some files, some sensitive folders and users which is there in the system. All those are the affected assets. In short, these four representation represent the essential dimensions of triage: severity, how bad; time, when; context, where in the attack life cycle; impact, who or what is affected. They form a balanced foundation that's simply enough for analysts to apply quickly but comprehensive enough for informed decision. After reviewing these factors, decide on your next step, escalate it to the incident response team, perform a deeper investigation, or close the alert if it's confirmed to be a false positive. A structured triage process like this helps ensure that time and resources are focused on what truly matters. Diving deeper into an alert. After identifying which alerts deserve further attention, it's time to dig into the details. Follow these steps to investigate and correlate effectively. Investigate the alert in detail. Open the alert and review the entities, event data, and detection logic. Confirm whether the activity represents real malicious behavior. Then, check the related logs. Examine the relevant log source. Look for patterns for unusual action that align with the alert. Correlate multiple alerts. Identify other alerts involving the same user, IP address, or device. Correlation often reveals a broader attack sequence or coordinate activities. Build context and timeline. Combine timestamp, user action, and affected asset to reconstruct the sequence of events. This helps to determine if the attack is ongoing or has already been contained. Decide on the following action. If there are incident of compromise, escalate it to the incident response team. Investigate further if more evidence or correlation is needed. Close or suppress if the alert is confirmed false positive, and update detection rules accordingly. Document findings and lessons learned. Keep a clear record of the analysis, detection, and remediation step. Proper documentation strengthens SOC process and supports continuous improvement. With the triage complete and the investigation in motion, MixKitty begins piecing together the puzzle. Every alert, log entry, and timestamp brings her closer to uncovering what the evil bunnies are up to inside the Azure tenant. It's time to connect the dots and reveal the bigger picture behind the noise. Now, let's get into the environmental review and get our hands dirty with the log analysis. Environment review. Before proceeding with the alert triaging, let's first review the lab environment. To get started, head over to the Azure portal and search for Microsoft Sentinel. So coming here, we can come here to search for Microsoft Sentinel, but we can also see it right here. We can click on that and okay, so sign in again. Let's do that. I hope that this time it doesn't give us any error. Let's use the same user that I tried initially. Enter the temporary access pass. Okay, we just need to do that. Then let's copy the password. and paste it in there. Click on sign in. Not enough. Your account is temporarily locked to prevent unauthorized users. Try again later. And if you still have trouble, contact your admin. Use the password instead. No, what we'll do is let's remove that. Click on here. Let's use another account and let's copy this account, paste that in, click on next, then copy this password, then paste that in, click on sign in. Not enough. Hopefully this works with all the cross fingers. Let's wait. And because I don't want to record it once again from the beginning or even from here, because this is my third time, I guess, that I'm recording it. I'm not sure, but yeah, this is my multiple times that I'm recording it. Okay, good. Looks it doesn't look like where I had to actually come in. Maybe because I gave the wrong URL. So let's open this. Hopefully it just opens it directly and doesn't ask me to authorize because I just logged in. Okay, that's loading. Hopefully that's a positive sign that it's loading. Yes, that's good. So let's come here and hopefully once again, thank God, I am grateful for today. So let's move into this and continue reading that. It says, then click on the Sentinel instance, go to the logs tab and select the custom log named syslog underscore cl. So I guess we need to click on this. So under the logs, we need to go to, I forgot the name, syslog cl. It's going to be present there. Under general, no, not on general. Let's close this. Why do I need a welcome screen? Yeah. Come on, I just don't. Yep. Okay. Where is it now? Under logs and okay, it should be here itself. Query one. Yes, this one. So let's click on run. I guess we should click on run itself. After running the query, so let's run this query itself. So let's click on run. That's going to do it. No results found from the last 24 hours by selecting it. Is that what we are supposed to get? No, right? Okay, let's click on this and go to logs. And let's go to the table here, custom logs. And yeah. Oh, that's good. Okay. Now we have finished this. So after running the query, the logs for this lab environment should be rendered. That's good. Now that you have reviewed the environment, let's proceed with the discussion of alert triaging in the next task. Let's click on check. But I just want to do my own analysis here and read through what we have found. Now I have never used Microsoft Azure's this thing, so it's also the first time that I'm trying to look at this and then get some view into it. Now, again, during my certification times, I have gone through it, but never as in hands-on experience of analyzing it. Actually, I have ever done that. Mixkitty goes triaging. Now that we have learned about triaging, let's move to the fun part. Working inside the actual SOC environment of the best festival company hosted in Asia. This is where Mixkitty will put her triage skills to the test using Microsoft Sentinel, a cloud-native SIM, which is the full form is given here, Security Information and Event Management, or SOAR, which stands for Security Orchestration, Automation, and Response. Those are basically some two methods of like performing or analyzing any events that is happening in your network or your system logs, or basically used for those things. Now, if there's an incident which has happened, you use these services to also figure out what are the potential ways that you can come back to the regular processes. Now, Sentinel collects the data from various Azure services, applications, and connected sources to detect, investigate, and respond to threat in real time. Through Sentinel, MixKitty can view and manage alerts, analyzing incidents, and correlate activities across multiple logs. It provides visibility into what's happening within the Azure tenant and effectively allow analysts to pivot from one alert to another. In this next part, we will explore how MixKitty reviews alert, drills into the evidence, and uses Sentinel's investigation tools to uncover the truth behind the evil bunny's attack. Microsoft Sentinel. I don't know if I'm even pronouncing that wrong, but whatever. I understand you understand. That's the end of it. In action. To start the activity, navigate to the Microsoft Sentinel and select your dedicated Sentinel instance. So, is it not the same thing? Okay. Then, under the Threat Management drop down, select the Incidents tab to view the incident triggered during the current time frame. You may also press OK button to expand the view as shown in the image below. Okay, so we are here. We have clicked on that. You know what? Let's put this into a different window. Move it to the right and bring this to the left. Now let's we had done that. Okay, this looks a little messy now. Yeah, we had clicked on this, which is what is that. Now we need to go to incidents, threat management incident. There are, I don't know, let's click on OK. Then go here. Oh no, go here. I don't understand what exactly is that step. You may also press this button to expand the view. Okay, that's just to expand the view. Now, what are the incidents that we have in this? I want to look at the incidents. Okay, select your. Then under the threat management drop down, this is the threat management drop down. Select the incident tab to view the incident triage during the current time frame. You may also press this to expand it. Okay, that's fine, but let me just click. What's going to happen? I guess it's trying to redirect into some other location, but what if I do that? Oh no. Okay, let's click on this once again. Incidents has been moved to Defender portal for the optimal unspecified. Okay, this has been moved here. Okay, as it wishes. Till then, let me even take a sip of water. Okay, so are these the same thing that we are supposed to be saying? Oh, okay, it says note in case that alert does not appear, refresh your browser. See the image below. Okay, I need to refresh the page. I could have just refresh this page. Oh no, cancel. No. From here, just refresh. Come on, at least now, at least. Okay, that did load. That's good. So we see so many high incident severities and so many medium. Low is 0, informational is 0. It says Linux privilege escalation is happening. Oh, these are actual tools. Sudo shadow access and toolkit exploit attempt. Okay, so someone is trying to do some privilege escalation in Linux, and that logs are presented there. From the task image, there are 8 open incidents. There are 865 open incidents. And 4 okay, 8 open incidents, 4 on high severity and 4 on medium severity. Know that these numbers might differ in your lab environment. Since we focus on addressing the most critical threat first, we will begin with the high severity alerts. These represents the potential compromise points or privilege escalation activities that could lead to complete host control if unchecked. To begin the triage, we'll examine one high severity incident in details, the Linux PrivX kernel module insertion alert. By clicking the alert clicking the alert, addition details appears on the right hand to the side. Okay, so let's click on this thing. Do we have any kernel exploit that they are talking about? I don't see it here, but okay, let's click on the first one that we have got. We see that the event is 21 alert, 0 bookmarks, and it's trying to do some privilege escalation, abuse of elevation control mechanism. Then the thing which it has identified, there's no comments about it. Okay, looks nice. It gives a lot of information, like even the creation time. Oh, that's good. Okay. Upon checking the alert, as seen in the above image, the following details can be initially inferred. There are 3 events related to the alert, and in our case, there are 20 events which is related to the alert. The alert was recently created, which is to the time. Know that this varies based on your lab instance. Okay, we see when it was created, which is 12th of 12th, 2025, and today's date is, what is today's date? Okay, it was done today itself. And oh yeah, even the time is close by. There are 3 entities involved in the alert. Now we see 10 entities who are involved in the alert. I just clicked on something and hopefully it doesn't log me out and break what's actually supposed to be seen. Okay, so this is just showing us in greater detail. So these were the entities which were involved in the alert. So it involves a workstation, some authentication, and these are all hosts, individual hosts which are involved in this. Okay, the alert is classified as privilege escalation tactic, and we also saw that. We can get a further detail from by clicking the view all details button, and we accidentally also did that, and we are in that page. It says, okay, if I just click on events or uh, refresh overview, let's go to the overview. It gives some timeline to us. It says, oh, okay, so it's trying to load something. Fine, I'm too messy with this. So understand, we also see similar incidents of it. Okay, that's good. Now what is this? Cancel. I'm not sure what this is. Okay. Okay. Now we see it in a better way. So we can also see similar incidents that has happened. Understanding related alerts. From the view above, you may notice that several alert points to the same affected entity. This helps us understand the relation and the possible sequence of events that impacted same host or user. When multiple alerts are linked to a single entity, such as the same machine, user, or IP address, it typically indicates that these detections are not isolated incidents, but somewhat different stages of the same intrusion. By analyzing which alerts share the same entities, we can start to trace the attack path from the initial access to privilege escalation and persistence. For example, if the same VM triggered the following alerts: root SSH login from external IP, the attacker gained remote access through SSH to the system, which is the initial attack. Then SUID discovery, the attacker looked for ways to escalate privileges. Then kernel module insertion, the attacker installed a malicious kernel module for persistence, basically like a backdoor. At this stage, MixKitty has reviewed high severity alerts, identified identified the affected entities, and noticed that several detections are linked together. The initial triage allows her to prioritize which incidents need to immediate attention and recognize when multiple alerts are actually part of large compromise. With this foundational understanding, MixKitty is ready to move beyond surface level triage and dive deeper into underlying logs, which we'll discuss in the next task. So, how many entities are affected by the Linux privilege escalation? That's 10. Then, what is the severity of the Linux sudo shadow access alert? It is critical. Sudo shadow, was it not critical? Let's come here. Sudo shadow, that is severity is critical, right? Oh, it's high. I'm sorry, it's high. HIGH. How many accounts were added to the sudo's group in the Linux privilege at sudo group? Okay, added to sudo group. For that we need to see closely. Sudo shadow. Okay. Uh, is there a way that I can search? Yes, it says. Let's copy this and search for it. Paste that there. Press enter. Uh, Now let's click on here. And what is the question here? How many accounts were added to the sudo's group? So let's click on events so that we can look in more detailed structure and incident overview. Let's see what does that give us. It's just a single digit. I'm hoping it's just one, which is wrong. Okay, yeah. No, I don't want those so many things. This is what has happened. Then what is? Let's click on view all so that we get more information about it. Now, how do I know how many users were added? Oh, it's a number there, but how do I know that these are the entities which were affected? So I don't think so. We'll get any. Oh, we see here. This was one account. What is this about? Is it 1, 2, 3, 4 timeline? It says detected Microsoft Sentinel. Okay. It was added. This is the time frames. Okay. But I'm not sure. I'll just try with 1, 2, 3, 4. 1, 2, 3, 4. Yeah, that's 4 itself. Yeah. So 4 accounts were basically added. So entities also means that what and all were the part of either the incident which has happened or to which it has happened. Okay, that's interesting. So in-depth log analysis with Sentinel. With the initial triage complete, Mixkitty now examines the raw evidence behind these alerts. The next task involves diving into the underlying log data within Microsoft Sentinel to validate the alerts and uncover the exact attacker action that triggered them. By analyzing authentication attempts, command execution, and system changes, Mixkitty can begin piecing together the full story of how the attack unfolded. If we go back to the alerts full details view, we can try clicking on the events from the evidence section. Okay, click on the. We did that, right? Let's try that on this. It's not working in this case. I'm not sure what's happening with that. Let's remove this. Let's go to some high vulnerability itself or high incident which is noted itself. Let's click on events. Then directly what's happening here. You know what? No, this is not a friendly way to view at it. Let's click on view all and then click on events, and that gives us the events here. And that gives us what exactly happened. Okay, that's nice, but that's from user query and results itself. But I don't see anything like that. Oh, we can. Okay, I'm sorry. So the message is also provided to us regarding it. So this was the host and what was the message of it. Okay. It was some unregistered authentication agent for Unix possible toolkit exploit attempts. Okay, fine. From this view, we can definitely see the actual name of the kernel module installed in each machine and the time it was installed. Yeah, kind of, yes. We can see some exploitation which is happening and what time it just happened. Diving deeper into this, we can try changing the raw events from a single host through a custom query. To do this, let's change the view into editable KQL, which is Custo query language. Okay. Query and find all the events triggered from app02. Press the simple mode drop down from the upper right corner and select KQL mode. So we need to simple mode. Where is the simple mode? Uh Queries. Okay, let's click on queries or functions. Is it somewhere here? Wait, where is that? Oh, here. Simple mode. And click on KQL mode. Okay. So we have an option to run queries there. Now modify the query with the following KQL given below. Set query now, date time. Okay, that's the date and time. That is already here, so I will not tamper with that. Syslog underscore CL, that's okay. Where host is equal to app02. Now let's change this. Where host host underscore s is equal to app hyphen 02, then close that. Then project timestamp. Let's copy this and see what output it gives. So let's replace these contents, paste that in there, then click on run, I guess. Yep. So click on run. Failed expression used, no, filter expression should be boolean requested ID. That doesn't work. Maybe the query that we are passing in doesn't is not linked to this, I guess. So oh no, it's equal to. I messed up there. Now maybe that should do it. Now it gives a boolean response like whether is it true or false. Yeah, and we get that. So this is the host, and we can see it from here. Host under S. That's what we want. Project, the timestamp, the host, and we want to also see the messages of it. Oh, that's interesting. So what if I want to see some other parameter like we have, is it part of any entities called as app2? No. But what if I want to try and change something, but I don't know much about it. So let's just continue with this. After executing the query, it can be seen that multiple potential suspicious event occurred around the installation of kernel modules. Is it? The session open for the user root by alias. Okay. The user backup user added to the group sudo by, okay. This is happening here. Authentication failure. Logon name is given there. Accepted password for the root from this IP on this port with SSH2. And CMD echo all this shadow file to shadow.back into cron tab. Then there's some activities which is happening there. Okay, I see that. Execution. After executing the query, it can be seen that multiple potential suspicious event occurred around the installation of the kernel module. Execution of the cp copy command to create the backup, to create a shadow file backup. Yeah, that's happened. Addition to the user account alias to the sudo's group, modification of the backup user account by root, insertion of the malicious mod.ko module. Is it? It is the point number 4. In our case, it's going to be a little different. And successful SSH authentication by the root user. That's what happened there. And we can also see it according to the timestamp. So when each of these events actually took place at what time. So that is very useful when we are analyzing it. Now let's continue reading here. Based on the surrounding events, including execution of the CP command to create a shadow file backup, the addition of the user account to alias to the sudo's group, the modification of the backup account by root, the successful SSH authentication by a root user, this activity appears highly unusual. The sequence suggests potential privilege escalation and persistence behavior, indicating that the event may not be part of normal system operation and warrants further investigation. Now that we have discussed the methodology of determining and revealing alerts, let's help Mixkitty complete the assessment by examining the remaining alerts and answering the question below. Let's answer to the question. What is the name of the kernel module installed in WebSR? Okay, let's copy that and replace it here. Maybe with the host itself, just replace the content there and run the query. Does that give any output? And yes, so we see that. You can also see it says kernel. And what is the question here? Name of the kernel module which is installed. Now, I don't know how do I see the kernel module. Oh, it's here. So it says netmon.ko. So let's copy that and submit it. No, it says insert module and huh? Did not accept that. Then what could that be? Type this. I don't see anything else. It says insert module name is equal to netmon.ku and it says no. What is the name of the kernel module installed in the web server 01? And I'm seeing that there. It says host is web server 01. And that is there only this much of information? Okay. So let's use this and yeah, it just gives this one. Or are we in the wrong thing? We are supposed to be identifying some different one, right? So let's go to here, then search for the one which they actually told us to search for, which is somewhere here, the one which had some high or the other one. So okay, you know what, let's only search for this one, Linux privilege escalation kernel module insertion alert. So coming back, let's go back to Microsoft incidents. I'll click on OK. Then search this. Is there anything? Pressing enter. No results. Okay, so we don't find this. I did not see that. But they told us that we can look at one more thing, in which we answered all these things. How many entries are affected by? Okay, let's try this itself. Uh, let's use this. Let's click on view all. And now try answering into this one. So that what we have to do here is click on events. Yeah, and from simple mode to KQL and replace, oh, so much is that system log CL where message. Okay, we need to replace this where host as message exploit message. Okay, let's replace that. And what we want to see is project timestamp and host messages. Replace that. Then answer coming to the question here. It says web server 01. Now replace it with this. Then run the query. What do we get here this time? A kernel, and it still says the same thing. Let me pass this itself. If it doesn't work, let's check it later. So it doesn't work. The answer you provided may not be in English. Please review and try it again. Let's click on hint. Replace the app 02 string in the QL with the web server 01 to see the events. And that's what I did, but I'm not getting the right answer. Now, why could that be? Or am I looking at the wrong thing? So, oh, it's something here. That's the wrong thing. So, we have something here in the bottom. It says malicious mod.ku. Okay, oh, okay, that's the one. No, no, everything is working fine. It is my mistake of being totally unaware of the stuff. What is the unusual command executed within the web server one by the ops user? So the ops user has sudo malicious. PWD is this, which is fine. This is echo. Yeah, this is the malicious thing which they have run. Let's copy that and hopefully that works. Click on check. Is this an extra thing? Or no, it did not get copied properly itself. So echo all these things. Let's copy that. Still is the same. It should come in that format. Slash. Then it's bin cp. No. What is the unusual command that was run? PW is fine. Once that is done, they accepted the password for the root and the password for alias, deployed echo bin setup, sudo session open for the root by the builder. Now the type audit. Okay, let's go into the temp and kernel something is happening. Sudo op the user is equal to root. Then failure log on. Okay. Uh, Fine, accepted for the pass user. Then what exactly is the question? What is the unusual command executed within the web server by the ops user? Unusual command. Which is that itself. I feel running that is unusual. Okay. I feel this is the most suspicious thing. The bin bash I and dev TCP. It's basically trying to connect to a different location. And yeah, I guess that itself is more malicious than anything else. So let me copy this entire content and paste it in there. Click on check. And yes, that's the right thing. What is the source IP address of the first successful SSH login to the storage? 01. So let's copy that location and replace it here. Then run the query. So what is the source IP address of the first SSH login? So that's going to be from here, I guess. 915. Yeah, it's going to be here. Was there any SSH login? Open session for the user. That's fine. Do I see any SSH login? Oh, okay. So it's 172.116.0.12. Accepted password for the root from this at that port number. Now, the reason why I'm so messing up this is because this is the first time that I'm ever actually dealing with it. So, yeah. Okay, what is the external IP that successfully logged in as the root to app 01? So let's copy that and replace it here with the storage 01. Replace that and paste that in. Click on run. Now, what led to the root access? So, do we see it says session open for the root by admin user? So that message says that root user was accessed, and this seems to be the address which has compromised it. So let's copy that And oh no, by looking at the format, it says no. So what this does is it's going to root bin bash I, and then it's this IP address to port 444. Then it's passing the contact. Okay. So here it says accepted password for the root from this host. So is that the thing? Because that has given the root access to the machine. Let's click on check. And yes. Aside from the backup server, what is the name of the user added to the sudo's group inside app01? Who was added to the sudo's group? User deploy added to the group by sudo using this. So let's put that in, click on check. And with that, we have finished the SOC alert triaging. So yeah, this is interesting. Now, this is the first time that I'm actually interacting with Microsoft Azure's thing for analyzing alerts and doing it. So that's the reason when I did a little bit of mess up in that. Okay, with that, let's wrap up this room and get into the Advent of Cyber's Day 11 challenge and meet you all in the day 11. So till then, stay happy, stay smiling. Thank you for watching. Thank you. Bye bye.